Hey everybody, and welcome back to another physics problem solved in the flesh. Two-dimensional kinematics, this time subtracting vectors. So, moving right in. Part A. Given the vectors A and B shown in video 35, determine B minus A. Okay, so if you didn't watch video 35, or if you forget, here it is, once again. We were looking at vectors, and this was the graph we were dealing with. We had vector A, 28 degrees above the positive x-axis, a absolute value of 44.0, and you had vector B, which was 56 degrees above the negative x-axis, which had a magnitude of 26.5. Okay, so if you don't have that, just write that down. Those are the vectors that we're dealing with in this problem. Okay. In part B, determine A minus B, without using your answer in A. Then compare your results to see if they are opposite. Okay, so since we are using A and B from the previous question, I'm just going to write them up here so we have them. Okay, so let's do B first. Following in with the colors we used in the previous video, Bx is minus 14.8, By is equal to 22.0, Ax is equal to 38.9, and Ay is equal to 20.7. So we already determined the components of the vectors A and B. If you want to see how we calculated that, go ahead and click on video 35, two-dimensional kinematics, vectors, example 6, and I take you through that in the beginning. Okay, but nonetheless, let's jump right into this problem. So we've got our vector components here, and we are charged with finding B minus A. Okay, so the way you want to think of this is when you subtract two vectors, your answer is going to be a vector. Okay, so let's say we call that new vector D. I'm not actually going to follow through with calling it D for the rest of the problem, but this is just an example. Okay, so B minus A is just another vector. You can call it whatever you want. And the fact, by understanding that it's just another vector, tells you that it's going to have an x component and a y component. In other words, I can actually rewrite this. You know what? B minus A is going to be B minus A with an x component and B minus A with a y component. So just like in the previous video, we're going to find the x component and the y component, and then we're going to combine them together to get our final answer. Okay, so first things first, let's find the x component. Okay, so B minus A x is equal to, okay, so Bx minus Ax, Bx is minus 14.8, Ax is 38.9, so minus 14.8 minus 38.9. You subtract those two, you get an even bigger negative number, negative 53.7. All right, now let's do B minus A y. Okay, so 22.0 minus 20.7. Subtract those two, you get 1.30. If you're following in suit 3 sig figs, you can see 3 sig figs in all four of these numbers. Right. Now we've got those. Now back to the question, just recap. Okay, we want to determine B minus A, right? B minus A. We stated that that is another vector. Now, a vector is a quantity that has both magnitude and direction. So we're going to have to find the magnitude and direction. Okay, so first, let's find the magnitude. Okay, so let me grab a different color here. So we'll do magnitude first, as always. And to find the magnitude, it is simply Pythagorean theorem, right? So we're trying to find the magnitude of B minus A. Again, if you want, you can call it something a bit more, compact. D, if you would like. Okay, so B minus A is going to be equal to the square root of the sum of the squares of the components, negative 53.7 and 1.30. Minus 53.7 squared plus 1.30 squared. All right. When you actually solve all this out and you take the square root, you end up getting 53.7. So there's the magnitude. So we're almost done. We still need a direction. So let's go ahead and find that. And as usual, we always find the direction by first finding, first actually drawing a diagram. Okay, so you've got your x, you've got your y. Okay, now notice here the x direction. Okay, so let me just move this down for a sec. Remember, the x is negative 53.7, the y is positive 1.3. So that means my x, I'm going to go negative 53.7 and then positive 1.3. This is going to be a rough scale, of course. So assume that to be minus 53.7 along the x. And we're going to go up to 1.3 on the y. Again, it's clearly not exactly to scale, but this is the general idea here. Okay, so negative in this direction, we go up here, and then making our resultant vector drawn like this, from the tail of the first vector to the tip of the second. And as usual, our theta gets drawn from the hypotenuse to that first vector right there. Okay, so there's our theta. Now, in order to find the angle, just as we've always done before, we're going to go ahead and do our tangent calculation because we're given the opposite and adjacent sides. So the easy trigonometric identity to use there would be tangent. So tan theta is equal to opposite. So the height of this triangle, this right angle triangle, is 1.30. The adjacent to this angle is the 53.7. Now, you might be asking, okay, why is she not putting in negative 53.7? And I'll be perfectly honest with you, there are some people who do. I personally don't put the sign in. I go based on the picture, okay? And you'll see why in a second. If you calculate this out, you take the inverse tangent of what this quantity turns out to be, you're going to end up with theta is equal to 1.39 degrees. That is the angle right here inside. That's 1.39 degrees. In other words, this angle is above the negative x-axis. So you don't need to put the signs in as long as you have the picture to tell you how to interpret what answer you get here. Okay? So we've got the magnitude, we calculated that earlier, that was 53.7. We found the angle is 1.39 degrees, and we know it's above the negative x-axis. So therefore, we can conclude for part A, therefore, B minus A is equal to 53.7, square brackets again for direction, 1.39 degrees above negative x-axis. And all our numbers are quoted to 3 sig figs, as they should be, since in the original problem, video 35, everything is given to 3 sig figs. So there is your answer to part A. Okay, so let's keep going. Part B now wants us to determine A minus B. So you already know what to do. We have to just determine that using the same process. It doesn't want us to use our answer to solve it. Okay, so let's compare and do A minus B and then compare it to B minus A. Okay. So A minus B, same as before, A minus B is going to be made up of components, right? It's going to have an x component, it's going to have a y component. So whatever this is, this new vector, it has an x part, and it has a y part. Okay, so let's go ahead and calculate the x part first. Okay, so A minus B x is equal to 38.9 minus negative 14.8. Be careful with your signs there. When you subtract a negative, you're essentially adding the second number. Okay, when you do that, you get 53.7. And when you do A minus B in the y direction, 20.7 minus 22.0 equals negative 1.30. And you're probably starting to notice that those numbers look very similar, except the signs are switched. And that's exactly what it should be. because after all, instead of b minus a, you're doing a minus b. Okay, so following in suit, we are going to determine the magnitude first. And just as we did before, it's Pythagorean theorem. The square root of the sum of the squares of the x and y. Okay, so a minus b, and again you put those straight lines on opposite sides, it means absolute value is equal to the square root of 53.7 squared plus negative 1.30 squared. And you'll notice it really doesn't matter what the sign is, right? It doesn't matter if this is negative or this is negative or both are negative, because you're squaring it. So the answer will come out to be positive in the end, regardless. And when you do this, you're going to get the same number. So the magnitude's the same, 53.7. And now let's take a look at the direction. Okay, so let me grab another page here. Let's keep working through. Okay, so we've got our magnitude, 53.7. We're going to go ahead and draw our graph. It's always, always, always a good idea in physics to draw a graph, no matter, or a picture, no matter what you're doing. It always helps clear up little things in the problem. Okay, now from our previous calculation, we had found that the x is 53.7 positive, the y is a negative 1.30. So in fact, when we draw our graph, it's going to be positive 53.7 up here. So we're going to, that's our x vector. Our y vector is minus 1.30. So when you add the two vectors together, you're going to get something that looks like this. Okay, and again we draw our theta from the hypotenuse to the first vector, and we're going to go ahead and calculate tan theta. Okay, so let me actually pull that down a bit. So tan theta is equal to opposite, which again, remember I'm not putting in the signs, 1.30 divided by 53.7, and when you take the inverse tangent of this quantity, you're going to get 1.39 degrees. And based on the picture, you can see that this angle is above, or rather below, the positive x-axis. Okay, so this angle is below the positive x-axis. Just something to make a note to yourself. So we have determined the magnitude, right, 53.7. We determined the angle, 1.39 degrees, below the positive x-axis. And so, therefore, a minus b is equal to 53.7 square brackets, 1.39 degrees below the positive x-axis. Okay, now to compare that to what we had earlier, okay, so earlier we had determined that, let me see if I can get both here on the screen. Nope, okay, that's okay. For part A, b minus a was 53.7, 1.39 degrees above the negative x-axis, and now we have 53.7, same magnitude, 1.39 degrees below the positive x-axis. Now, if you remember the question, it's saying, compare your results and see if they are opposite. Now, you got to be careful in physics because we don't just use words for no reason. The word opposite when it comes to vectors means same magnitude, opposite direction, okay? So, let's check. Does that make sense? You've got one vector, so let me shift this up. They both have the same magnitude, right? So that's a yes. One is going 1.39 degrees above the negative x-axis. Clearly that is an exaggeration of the angle, but nonetheless, you get the idea. And the other is 1.39 degrees below the positive x-axis, so it's going in this direction. Sure enough, those two vectors are opposite. They have the same magnitude, and they are going in opposite directions. So therefore, a minus b and b minus a are indeed opposite vectors. Wow, that was a long video, but nonetheless, there it is. I hope you guys enjoyed it. I hope you learned something from this video. Please feel free to share this on Facebook or Twitter if you'd like to share it with someone who you think could benefit from watching this, and subscribe to my channel so you can catch more physics videos in the flesh. Thank you guys for watching, and I will catch you later.